Okay, what we're going to look at now is homework problems for 15.3. Let's start with number 2. And f of t, the partial of 92/60, is defined to be the limit h approaches 0, f of 92 plus h, 60, minus f of 92/60 all over h. So we're going to let h be 2 just for an example. And then we have this, if you do this part of it, that part's going to be 3. Well, it'll be f of 94, which is 111 minus 105. F of 92 divided by 2 is going to give us 3. And if h is negative 2, then that part without the limit is going to be 100 minus 105 divided by negative 2, which is 2.5. So if we take the average, it's, let's say, 2.75, the average of those two. So what this means is that when the actual temperature is 92 degrees and humidity is 60%, the rate of change in the perceived temperature is 2.75 degrees for every 1 degree actual temperature increase. So as the actual temperature increases by 1 degree, it's going to feel that it's going to feel like it's going to really increase by 2.75%. Now, if you do the same for the humidity, and we let h be 5 only because that's the chart increments at 5. So this part of it is going to be 108. That means at 92 degrees, 65% humidity, we're going to get 0.6. And when we do negative 5, so we're going to do 55% humidity. And again, I'm just looking at the chart. So the average is 0.5. It's between these two. So again, this means when the actual temperature is 92 degrees and the humidity is 60%, the rate of change of the perceived temperature, I mean what it actually feels like outside, with respect to humidity is 0.5, which means the perceived temperature increases by 0.5 degrees when the humidity increases by 1%. So that's a really good exercise to understand the partial derivatives. Let's look at number 10. And this is asking us to draw. Well, first let's draw. Let's draw it. We have z squared, if we square both sides, is 4 minus x squared minus 4y squared. If we let y equal 0, we're in the xz plane. And we get z equal the square root of 4 minus x squared, or we get z squared equals 4 minus x squared, which is half circles in the xz plane, and the radius is 2. When x is 0, we get z squared equals 4 minus 4y squared. And those are ellipses. And again, they're in the upper half because of the square root. We're in the we're above the xy plane. They're half of the ellipse. Okay, we're going to draw this. And if z is 0, we have x squared plus 4y squared equals 0, and these are half an ellipse. So if I draw this, then I get in the xz plane, I get a circle. Radius 2, this is 2, 2, negative 2. And in the xy plane, I'm getting ellipses. So, and those traces are going to be ellipses. And in the yz plane, I also get ellipses. So they're going to go like this. So those look like that, and these come around like this. Now, well, I'll come back to the picture. I want the partial of x with respect to partial of f with respect to x at 1, 0. So the partial of f with respect to x is going to be bring down the power, leave the expression alone inside radical, subtract 1, and then take the derivative of this with respect to x. So y is a constant. So the derivative of 4 is 0. That's 0. Derivative of x with respect to x of negative x squared is negative 2x. And the derivative of y is 0. So this is going to be negative x over the square root of 4 minus x squared minus 4y squared. And at the point 1, 0, that's going to be negative 1 over the square root of 3, which is the slope of the tangent line. And the partial of f with respect to y that's a constant, so it's just going to be negative 8y. And at the point 1, 0, that's going to be 0. So we have a horizontal tangent line because that's the slope of the tangent line. And so the point that we have that we're going to look at is 1, 0. Now plug those into z, and we have square root of 3. So at this point, 1, 0, square root of 3, let's get the picture. Okay, 1, x is 1. 1, 0, square root of 3. Say it's right there. Let's do this in red. The partial of x is the slope in the, it's going to be parallel to the x-axis. So that slope is 1 over square root of 3. And then this one's parallel to the y-axis. And this slope is 0. This is partial with respect to y at 1, 0. And this is the partial with respect to x at 1, 0. And that point right here is 1, 0, square root of 3. So there's a good picture. Actually, guess I made a mistake. This should be a minus. Minus 1 square root of 3. Okay, just okay. All right, let's look at number 20. Okay, we're going to use the quotient rule. It's the denominator times derivative of the numerator. T is a constant, so derivative of s is 1, so this is just going to be t squared minus the numerator times the derivative of the denominator with respect to x is 2s all over the denominator squared. So I'm using the quotient rule. So when I simplify that, I just get t squared minus s squared all over s squared plus t squared squared. Then if I take the partial with respect to t, this time s is a constant. Again, I have to use the quotient rule. S is a constant, so this is just going to be derivative of t is 2t, 2ts, the numerator, times the derivative of the denominator. S is a constant, so that's 0 plus 2t all over the denominator squared. If you simplify this, we get 2ts cubed over the denominator squared. Okay, let's look at 26. Here's one with 3 variables. Okay, f with respect to x. Y and z are constant. So in that case, this is a constant. So we're just taking the derivative of x squared is 2x. and we leave the constant alone. That's it. Okay, with respect to y, this is a constant, so we just leave x squared alone. Take the derivative of e. Z is a constant. Let's do this in blue. So to take the derivative of e, it's itself times the derivative of the exponent, and the derivative of the exponent is just going to be z, because the derivative of y is 1. And then let's do this one in green. Okay. Here x is a constant and y is a constant. So again, the constant just stays alone. The derivative of e is itself times the derivative of the exponent. But here y is a constant, so derivative of z is 1, so it's just going to be y. And we're done. 42. Here we have to do this implicitly. So with respect to x, we're doing z with respect to x. So we have product rule here, y times derivative of z with respect to x, plus z, the derivative of y with respect to x is 0, equals the function, the expression goes on the bottom. Now the derivative of that, derivative of x, is 1. Then we have derivative of z with respect to x. So we have to get this all together. Let's solve this. So we have x plus z. Let's multiply both sides by the denominator. Get all the zx's on one side. Factor out a zx. And then divide. And that's our final answer. Okay, do the same thing with respect to y. The original is this, remember. Again, it's the product rule, so it's the first times the derivative of the second plus the second times the derivative of y, which is 1 here. X plus z function goes in the bottom. Derivative of the function, the derivative of x with respect to y is 0. And then derivative of z is with respect to y. So again, we multiply both sides by x plus z. Get all the zy's to one side, factor them out. I'm going to distribute this. That's a negative because I'm bringing it to the other side. So the derivative of z with respect to y is going to be this. And you can do this implicitly, just like we do with regular derivatives. Okay, one more. Actually, let's do 2 more. 50. Z with respect to x, y is constant, so the constant just stays there. We take the derivative tangent, is secant squared 2x, and we have to come back, take the derivative of 2x, which is 2. So it's 2y secant squared 2x. Z with respect to y, this time x is a constant, so tangent 2x is a constant, that just stays the same. Derivative of y is 1. So we're done. Okay, let's do a second partial with respect to x. So we go back to this one and take it with respect to x. Again, y is a constant, so it's just going to stay out in front. That's a constant. Derivative of secant squared is 2 secant 2x times derivative of secant is secant tangent times the derivative of 2x, which is 2. So this is going to be 8y secant squared 2x tangent 2x. Second partial with respect to y. Well, there is no y's here in the first partial with respect to y, so that's going to be 0. Tangent 2x is a constant. Partial z x y. So we do y first. So we're going to go back to this one. We're going to take the tangent 2x with respect to x. Remember, we do y first and then x second. So that's going to be secant squared 2x times derivative of 2x is 2. Remember, the derivative of tangent is secant squared. And derivative of z with respect to x then y. So first we do x, which is, let's go back and write it. It's 2y secant squared 2x. That's zx. So if we want to take that with respect to y, the derivative of y is 1. The rest is a constant, so that's just going to be 2 secant squared 2x. And look, these are the same. So remember, if they're continuous, then they're going to be equal. All right, one more. Let's look at 58. Okay, partial of f with respect to t. So x is a constant, so the constant is just going to stay there. The derivative of e is itself. The derivative times the derivative of the exponent, which is with respect to t, so that's just negative c. Partial with respect to t again. So we're going to do this with respect to t. All this is a constant. E is itself times the derivative with respect to t is again minus c. So that's going to be c squared, x squared. And do it again with respect to t. So the first, all that's a constant. Derivative v is itself. Come back, take the derivative with respect to t. So that's negative c. So that's negative c cubed. Okay, then they want, so first we do with respect to t. Let me just write that here. That was minus cx squared e to the negative ct. This is f of t. So now do that with respect to x. So anything with t or constant is constant. So that's constant. So we take the derivative with respect to x. That's going to just be 2x. That's without that. Now we come back and do it with respect to x again. X is here, derivative of x is 1, everything else is a constant. So that's just going to be minus 2c e to the minus ct. Derivative of x is 1. And all this is a constant. Okay, so I hope that helps you with your homework.